So this time we will be talking about infinite limits and limits at infinity. So although we had some of this already. Infinite limits and limits at infinity. So we had indeterminate form 0 over 0 already, no? Another indeterminate form is what we call infinity over infinity. So we have the indeterminate form, indeterminate form infinity over infinity. We say that the quotient of the form f of x over g of x has the indeterminate form. Indeterminate form. When I say IF, I mean indeterminate form. Huh? Infinity over infinity at x equals a, at a, if the limit of f of x as x approaches a certain number, let's say a, is equal to either positive infinity or negative infinity. Same thing for the limit of g of x as x approaches same number a. So we have the limit either positive infinity or negative infinity. And also we say that limit or as x approaches a of the quotient of f of x and g of x takes the indeterminate form, takes the indeterminate form infinity over infinity. So if you have a quotient and the denominator gets a value that is 0, the numerator gets a value also that, infinity, either negative or positive, same thing for the numerator, then that quotient is what? Is indeterminate form, no? Okay? So, and we say that the limit of such quotient takes the indeterminate form infinity over infinity. So if this limit, again, limit of f of x, limit of g of x separately, either positive infinity or negative infinity. Combination, positive infinity over positive infinity, negative infinity over negative infinity, positive infinity over negative, negative over positive. So as long as infinity. So that is indeterminate form infinity over infinity. So I have a theorem handling such case. So we have number 1. If f of x approaches, let's say, 0 from the right through positive values, again, what does it mean? F of x, the value of the function, is approaching 0 through positive values as x approaches a, and let's say c is positive, then the limit of c over f of x, take note that c is a constant, as x approaches a is equal to positive infinity, or simply infinity if you want. If I have c that is negative, then this limit as x approaches a of c over f of x is equal to negative infinity. Okay? So, if your f of x, the denominator of this quotient, is approaching true positive values, meaning getting to 0 but coming from positive values. Number 2, if f of x approaches 0 but this time through negative values, as x approaches a specific number a, and if number 1 c is positive, then this limit as x approaches a of c over f of x is equal to negative infinity, because c is positive but f of x approaching 0 through negative values. So a constant that is greater than 0 over a number that is getting 0 but through negative values, you will get negative infinity as the limit. And if c is negative, then this limit as x approaches a of c over f of x is equal to positive infinity. So again, take note that f of x approaches through negative values but going to be 0 through negative. This c is negative because less than 0, negative over negative, positive, so it is becoming positive infinity. Of course, these limits do not exist, but specifically, they are getting bigger and bigger without end, either negatively or positively. Okay? So, examples, if we are asked to evaluate number 1, limit as x approaches negative 3 from the left of 4 over x plus 3. So, the numerator is constant, positive. The denominator is going to be 0, but take note, negative 3 from the left, approaching negative 3 from the left, that is negative 3.1, negative 3.2. So, negative 3.1 plus 3, so this is going to be negative. So, going to be 0 but through negative values. So, hence, this is positive over negative, therefore, negative infinity. Okay? So, again, this approaches what? Approaches 0 through negative values. So, hence, so the limit is what? Negative infinity. Okay? Yeah. You can write if you want 4 over going to be 0 through negative values. That is allowed. But it is not allowed to have 4 over 0. But if you put negative on top, so it means getting to be 0 but through negative values. So you have negative infinity. Okay, so let me write that so that at least you know why, So this is positive 4 going to be 0 through negative values. So therefore, negative infinity. Number 2. So if I have limit as x approaches, let's say, negative 3, but this time, coming from the right, same, no? 4 over x plus 3. So coming from the right, so it means negative 3 going to be, x going to be negative 3, but coming from the right, so that is negative 2.9, negative 2.999. So plus 3, so this is going to be 0 but true positive values. So 4 over what? Over 0 true positive values. So that is going to be positive infinity. Any question, guys? Guys? From which we can now conclude that as x approaches negative 3, so the totality both from the left and from the right of 4 over x plus 3, since they don't have the same behavior, does not exist. No? But let's say they are both positive infinity, then you can write this equals negative equals positive infinity if they have the same behavior. Okay? So what does this mean? Both from the left and from the right. Since they don't have same direction from the left and from the right, so simply does not exist. Again, don't put equal, ha? Number 4. If I have, let's say, limit as x approaches 2 from the left of x minus 5 all over x minus 2. So the numerator, the limit is going to be negative 3. No? The denominator, the limit is going to be 0. But since from the left of 2, so x minus 2 is what? Is going to be 0, but true negative values because x is less than 2. Okay? So this means we have negative 3. So I can write here negative 3 over going to be 0 but true negative values. So this is what? Negative infinity or positive infinity, guys? Guys? Huh? Guys? Oy, guys? Guys? So positive infinity, no? So as x approaches 2, but this time from the right, x minus 5 all over x minus 2. If you have a question like this, so again, actually you start with the denominator so that you know the behavior. Kasi if the denominator is not 0, you can proceed immediately. You can apply substitution technique. So the denominator is going to be 0, but since greater than to the x, because coming from the right of 2, so getting to 0 but through positive values. X minus 2 is going to be 0 through positive values. The numerator is going to be negative 3. So this is negative 3, the limit, over going to be 0 through positive values. So this is negative infinity. Okay? If you have positive infinity, it's alright not to put positive. Huh? It's alright to have just infinity, if positive infinity. So the totality, as x approaches 2, what's the limit of x minus 5 all over x minus 2? What's the totality? Do they have the same direction? No, no? So it means the limit does not exist. Okay? So again, don't put equal, ha? Because some of you don't really serious watching the videos that I had, or did not really listen or did not attend any session. So that's why they don't understand what we mean by solving limit, no? So there are so many writing incorrect lines of solutions, no? Even though the answer is correct, but if you have mathematically incorrect way of writing every line, then I will not make it correct, okay? So what about if I have this limit, no? Limit as x approaches square root of, as x approaches to 1 from the left of 10 minus x all over x minus 1 quantity squared. The denominator is going to be 0, but since it is squared, going to be 0 always through positive values. Why? Why is it always going to be through positive values? Because it is being squared. Remember, whether negative or positive, the result, So even though 1 is to the left of, x is to the left of 1, 1 minus a value of x that is less than 1 minus 1 is going to be 0 but true negative. But since it is squared, positive still. Okay? And this is 10 minus 1. So 3 going to be 3 the square root of 9. No? So this is equal to 3 over going to be 0 through positive values. So this is positive infinity. Okay? Okay, guys? So what about limit? Number 8. Limit as x approaches 1 from the right of square root of 10 minus x over x minus 1 quantity squared. So again, this is going to be 0 through positive values because the exponent of the denominator, in the denominator, the exponent of x minus 1 is positive even. So this is going to be what? 9, then square root is 3. So that is 3 over, going to be 0 through positive values. So that is positive infinity. Okay? A question, guys? Guys? Huh? So, we now have, finally, if I have limit as x approaches 1 of square root of 10 minus x all over x minus 1 quantity squared. Okay, so since this is whether to the left or to the right, so this is going to be 3. This is going to be 0 through positive values of positive infinity, no? Or because of 7 and 8, same behavior, so we can say that this is positive infinity. So the limit as x approaches 1, meaning two-sided limits. Okay? So the solution for number 9 is 7 and 8 before you can conclude 9. But although this is even, you can go directly if you want. What about if you have limit at infinity? No? Let's say I have limit as x approaches positive infinity of, let's say, 4x over 4x minus 1 all over x minus 2. The denominator, so the limit of the numerator, as x becomes large, this is going to be large, no? Positive infinity. If x gets large, 4 minus x is very large, minus 1. Minus 1 will not affect this large number. A very large number, let's say 10 trillion, our debt from China, no? 10 trillion minus 2. Minus 2 will not affect, let's say, minus 2 pesos. No, that's nothing against 10 trillion. So that is negligible. So it's still very big, no? Going to be positive infinity. So it means it is indeterminate form, infinity over infinity. Okay? So the technique is to divide both the numerator and denominator by what? By highest power of x in the numerator and in the denominator. What is the highest power of x that you can see in the numerator? Highest power. So the highest power is 1, no? In the denominator, the highest power is 1 also. So we divide by x, no? Both the numerator and denominator. So divide by x. So for x minus 1 and over x. The denominator also, you have to divide by x. So this is equal to limit as x approaches positive infinity of, this is 4 x over x, that is 4, 1 over x, that is 1 over x over x, that is 1, minus 1 over x, that is 1 over x. Okay? Now, if you have 1 over x, if x is very big, what happens? Again, if x is very big, if you have, let's say, limit, did I discuss that already to you? Let me go back here. So let's recall. I don't think I had that with you. No? So let us consider this graph, guys. Let's say I have this function whose graph is given by this, and it is approaching x-axis, approaching y-axis, going up, meaning as x goes to 0, it goes upward. As x goes to the right, it goes to 0, no? Meaning at y equals 0. Same thing here, no? Yan. So that behavior, okay? Actually, that's the graph of what function? F of x is equal to 1 over x. If I have this limit, as x approaches, let's say, positive infinity, meaning as x goes to the right, what happens to 1 over x? 1 over a very big number, it's going to be 0. Okay? If I have limit as x approaches negative infinity, so 1 over of 1 over x is still going to be 0. Is that clear, guys? So, yan. Okay? So, let's now have. But also, if I have limit as x approaches 0, 0 of, from the right, of 1 over x, this is going to be 1 over 0 through positive values of positive infinity. Limit as x approaches 0 coming from the left of 1 over x, 1 over going to be 0 from the left, so that is negative infinity. Okay, so we can now go back here. So, what's now the limit of this? Now, the limit of 4 is 4. The limit of 1 over x is going to be 0. Okay? So, 1 over x is going to be very big, 1 over very big. So, we use this. So, that is going to be 0. Okay? All over. So, limit of 1 is 1. Limit of 1 over x is going to be very big. So, that is going to be 0. So, it is equal to 4. So, that's how to solve it. Or, there is another way. Or, you are going to apply this principle. So, let us have this principle. If I have, let's say, limit as x approaches, let's say, ay positive or negative infinity. Positive or negative infinity. Then, I have a to the m, a sub m, x to the m, plus a sub m minus 1, x to the m minus 1, plus a sub m minus 2, times x sub x to the m minus 2, all the way to a sub 1 x, until we have a constant term. Same thing for the denominator. Let's say the denominator is also a polynomial. Yan. Let's say b sub n, x to the n, plus b sub n minus 1, x to the n minus 1, plus b sub n minus 2, x to the n minus 2, all the way to b sub 1 x plus b sub 0. Now, if you have this limit depends on the limit of, depends on limit of as x approaches either positive or negative infinity of, kukunin nyo lang yung highest power. You just get the highest power. This is m, ha? M. Pwede nyo nang i-reject yung lower powers of x over b sub n x to the n. So, kung ano man yung limit daw nito, yun din ang limit nito. Okay? Yan. So, let's say I have this problem, no, limit. What was the given? As x approaches positive infinity, no, of 4x minus 1 all over x minus 2. Was that the problem, guys? So ang kukunin ko na lang yung highest power. Limit as x approaches positive infinity ng 4x. Hindi daw nakaka-affect kapag ang x very large, hindi nakaka-affect ang behavior ng numerator, yung negative 1. Same thing here, yung 2 hindi nakaka-affect sa behavior of x minus 2. So I can just have it x and drop the negative 2. Meaning all the rest of the terms you can drop. So we can cancel that. So that is simply 4. And the limit of a constant is 4. Okay? Which was the same limit like what we had before. So that's how to do it. Another one. Let's have another one. Number 2. If I have, for instance, limit as x approaches negative infinity of 4x squared minus 3x plus 4 all over x minus 2. So this is equal to the limit of the numerator going to be positive infinity. Kapag ang function is polynomial at ang x nagiging very big, either negative infinity or positive infinity, nagiging infinity yon. Bakit negative infinity? Dito siya dependent sa highest power. So dominated niya yung sign ng lahat. Kasi naka-square, kahit negative, positive pa rin. Ito, going to be positive infinity or negative infinity. Yan. So this takes the form of infinity over infinity pa rin. So that is indeterminate form. Okay? So, the shortcut, ano daw ang shortcut? Para mabilis. Instead of dividing by the highest power, so, pakita natin. Ano yung highest power? X squared, divide the x squared. Divide muna natin ang highest power. Divide by x squared. Divide by x squared. So, all over. Divide to ng x squared. So, 1 over x squared. Ito, di-divide mo ng x squared. Yan. Okay? So, this is going to be, kaya lang yung denominator, going to be very big. Very big, no? Yan. So, this is going to be 4. Yan. This is going to be very big. But how big? So, this is positive infinity. The denominator is going to be 0. This is going to be 0 also kasi 2 over very big going to be 0. Okay? So, kaya lang, going to be 0 through what values? Kasi ang numerator, ito going to be 0. Going to be 0. Yung denominator, kaya lang, going to be 0 through what values? O, mag-assign tayo. Negative infinity, let's say, kahit mga negative 100, no? 1 over negative 100 pag ni-square, positive, then square. Then minus 2 divided by negative 100. So, ito pala, sorry. Dinivide ko ito ng x squared. X lang to. 1 over x. So, 1 divided by negative 100 minus 2 divided by, this is going to be 100 squared kasi naka-square, so positive pa rin. So, minus 2 over 100 squared. So, this is going to be two negative values. So, therefore, this is going to be negative infinity. Or, yung technique, para mabilis, limit as x approaches negative infinity of 4x squared minus 3x, kukunin na lang natin yung highest power. Limit as x approaches negative infinity ng what? Ng 4x squared over, ano yung highest power dito? X. And this is simply 4x. X is going to be negative infinity times 4, so that is going to be negative infinity. Okay? Limit as x approaches negative infinity of 4x na lang yan. And what's the limit? 4 times very big negative, negative infinity. So we get the same result. Okay? So that's the technique. If you have a polynomial over polynomial, and you have infinity over infinity, so that's the technique. Did you understand, guys? Any question? Or if I have limit, number 3, as x approaches negative infinity of this quotient, 6x cubed minus 3x plus 4, negative 2x to the fifth plus 2x cubed, then minus 3. Oh, polynomial over polynomial. We can use this technique. So, this is equal to limit as x approaches. Same behavior siya. Pag kinuha natin yung highest power over, ano yung highest power dito? Negative 2x to the fifth. Pag sinimplify, simply negative 3 over, so that is negative 3, pwede kung sa taas na lang ilagay negative. Negative 3 over x squared. Okay? Ang ilalim, always positive kasi naka-square. Pero very big. A constant over very big, pwedeng isulat yan ng ganito. Yan, di ba? Pero, naka-square to. Kaya this is going to be 0 times negative 3. So, 0 pa rin. Okay? So, again, this is very big, going to be 0. Kahit pa hindi actually naka-square to eh. This is still 1 over very big. So, that is what? Going to be 0. No? This limit times negative 3. So, 0. Okay? Guys? Oh, let's have this one. 4. Limit as x approaches 3 of 1 over x minus 1/3 times 9 over x minus 3. So, you cannot split this into product of limits. Why? Because the limit of this is what? Is not existing, no? The second factor. So, what we do, we try to get the limit of what? So, again, ang limit kasi ng 9, ang limit as x approaches 3, ng 9 over x minus 3, from the left, going to be what? 9 over going to be 0 through negative values. Kasi from the left ng 3. So, x minus 3 is going to be 0 from the left or through negative values. So, this is negative infinity. Ang limit naman, as x approaches 3 from the right, obviously, positive infinity. Ito magiging 0 from the right naman. Negative infinity. Positive infinity. So, the limit of this does not exist. So, we cannot split the limit. But let's see, baka mag-exist ang limit ng totality. Okay? Now, if I'm going to get the LCD of the second factor inside the limit, so at least this is going to be 0. But let's see. If I will have the denominator 3x, this is 3 minus x, right? Am I right, guys? Getting the LCD. Times 9 over x minus 3. Okay? So I can now cancel this. So this is now going to be limit as x approaches 3 of 9 over 3 is what? Is 3. So it is now 3 over x. Okay? But what's the limit of 3 over x? What's the limit of 3 over x? Guys, by the way, this is 3 minus x, x minus 3, negative pala ito, negative. Kasi baliktad to eh. Pag pinactor out ko ang x minus 3, cancel yan sa x minus 3. I cannot cancel this immediately, guys. Sorry, nabigla ako. Ay, hindi naman kayo nagsasalita. Siguro hindi naman kayo nakikinig. O hindi nyo naintindihan. Hilong-hilo na kayo. Yan. So, pag pinactor out ko yung negative, yan. Ito, over to, negative 3 yan, ha. Ito, pag pinactor out ko to, sisimplify ko na ito. Pag pinactor out ko, negative of x minus 3, yan, magka-cancel yan dyan. Na? Yan. Patas 9 over 3, so negative 3 over 8. So, this is going to be negative 3 over 3, negative 1. O, see, the limit exists, and it is equal to negative 1. Okay? A question, guys? Let's now talk about this another theorems, no, on limits. So there are also theorems handling trigonometric functions na nagsi-0 over 0. So, ito yan, guys. Yan, naghang na. What theorems? We have the following theorems. Number 1, limit as x approaches zero of sine x over x. Yung iba theta yung ginagamit. Theta approaches 0 is equal to 1. Okay? But what is the condition for x? So, let x be any real number, or x is in radian measure. Let x be an element of real number, or in be in radian measure. Be in radian measure. Radian measure, not in degrees. Pwede siyang real number or radian measure. If you have limit of sine x over x as x approaches 0, that is equal to 1. By the way, for the proof, you can go over with any book in calculus, or you pwede yung i-google. May mga proof yan. Hindi na natin ipo-prove. No? So, but you can have numerical approach if you want. At least may magkaka-idea ka na approaching 1 yan. Yung numerical approach natin. If I have 1 of minus cosine x all over x as x approaches 0, it is equal to 0. So, remember these two theorems. How to apply this? Number 1. Let's say I have limit as x approaches, let's say 0, of sine x over 3x. So first, I can factor out 1/3 and then take the limit of sine x over x as x approaches 0. So this limit is this number 1, and that is equal to 1 times 1/3. Therefore, we have 1/3. Okay, guys? If I have limit as x approaches, let's say 0, of sine 7x over 3x, yan. So that is equal to limit. I can factor out what? 1/3. Then as x approaches 0. But I want this angle 7x to be the same with the denominator. But this is x only. So I will put 7 also. But if I put 7, I have to put in the numerator 7. Para 7 over 7, cancel. Then, paras na to, 7x, 7x. Kasi kailangan kung x ang angle, x din ang denominator. I can write this 7 outside. This 7 over 3. Limit of sine 7x over 7x. Ang problema natin, this is x approaching 0. Dapat, Parehas din. Pero as x approaches 0, ang 7x nag-approach din sa 0. Again, as x approaches 0, anong nangyayari sa 7x? Guys, mag-approach din sa 0. Kaya pwede kong palitan yung x ng 7x approaching 0. O, parehas na yan. Sine of 7x over 7x. 7x approaches 0. Parehas na x, x, x. 7x, 7x, 7x. So this is now equal to 1. So what's the limit, guys? 7 over 3 times, what's the limit of this? 1. So it is now equal to 7 over 3. Okay? Oh, did you understand that, guys? I don't think so. Okay, guys. Naka, hindi na nagsasalita. Buhay pa ba itong mga to? Yung iba yata umuwi na. Buhay pa ba, guys? Walang chat ba? Nasaan ba yung chat ng mga to? Ayan. Ilan ba kayo? 15? 15 ang buhay. Yan. Patas ng finals, 3 na lang ang buhay ang pasa. Okay, so let's have another one. Number 3. Limit. As x approaches 0 of tangent of 3 theta. Theta naman, ang ating argument at variable. Ay. Theta. Over 5 theta. Yan. So again, dapat ito na going to be 0. Ito going to be 0. So indeterminate form. Ang problema ay, children. Ang problema natin, hindi naman siya sine function. Hindi naman tayo pwede mag-cancel ng theta kasi nasa loob ang theta. Unlike pag polynomial, pwede tayong mag-cancel na what? Na mga factor, no? Ito hindi. So, iliwat natin in terms of sign. Limit. As theta approaches 0. Magiging ano yan? Sine of 3 theta. Ang problema, yung 5 hindi naman 3 theta. Gagawin kong 3 theta. Pero yung 1/5, ilalabas ko. Hindi ko kailangan. Yan. Kasi naglagay ako dito ng 3, dapat maglalagay din ako ng 3. 3 over 3 cancel. Yung 1/5, hiwalay ko. At hiwalay ko rin yung, di ba ang tangent? Sine over cosine. Ito yung cosine. 3 theta. Okay guys? Sine over cosine, tangent. 3 theta yan. Cosine 3 theta over cosine 3 theta. Kailangan kasi parehas ang nasa sine, ang nasa loob ng sine 3 theta sa denominator dito. Walang problema sa cosine 3 theta. Kasi ang cosine ng 0, not 0. It is actually 1. So, ito nag-exist ng limit. Pwede ko nang hiwalay yan. Limit as theta approaches 0. Again, pwede kong gawin itong 3 theta. Diba? Pag ang 3 theta, pag ang 0, ang theta nag-approach sa 0, ang 3 theta nag-approach din sa 0, guys. Ito naman, 3 pips. Limit of 1 over cosine 3 theta. Yan. As theta approaches 0. Okay? Yan. Ito, equal yan sa 1. Ito, times 3 pips. Cosine 3 theta, anong theta mag-approach sa 0? 1 over cosine ng 0. But cosine ng 0 is 1. So, finally, 3 pips. Okay guys, baka pag nag-solve na naman kayo kung ano na naman pag gagawin nyo. Limit. As x approaches 0 of 1 minus cosine of 4x over 7x. Yan, hindi pareho. So, anong gagawin? Dapat kung 4x to 4x din. Labas ang 7. Magmumultiply ako ng 4 sa ilalim. Magmumultiply ako sa numerator ng 4. Okay? Kasi bala ko magmultiply ng 4 sa ilalim. At nilabas ko na yung 7. 1 over 7. Ito yung 4. Cancel dito yan. Kung constant, pwede yung lumabas-pasok sa loob, Basta constant. Yan, parehas na. Parehas sa theorem, pwede ko namang isulat ang x approaching 0 as 4x approaches 0. Okay? Yan. 1 minus cosine 4x all over 4x. O pare-paras na yan. 4x. 1 minus cosine of 4x 4 over 4x all over 4x. 4x approaching 0. So equal na yan sa 0. So times 0. So 0 na yan. Okay? Yan. O remember ha, as x approaches 0, anong nangyayari sa 4x? Nag-approach din sa 0. Kaya itong behavior na yan, I can replace that by 4x approaching 0. Okay? Okay guys, still alive? Guys, y naman. Approaching pi. Yan, approaching pi. Of what? Of sine of x over 2x minus pi. Yan. 2x x minus pi lang pala, sorry. Dapat x minus pi lang para approaching 0. Sin pi, so dapat pala y. So ang ating variable. Meron pag live, no? Ayaw mapura. Meron pag live. On. Ayan. Y tayo y. Sin y, y minus pi. Ayan. Kapag ang y nag-approach sa pi, sin pi going to be 0. Pi minus pi going to be 0. So, indeterminate form. Hindi naman tayo pwede mag-cancel ng y minus pi. Walang makakancel. So, iliwat natin in the form ng yung sin x over x as x approaches 0. Kaya lang approaching pi ito, no? Yan. Etong sin y, pwede kong isulat yan, children, ng what? Ng sin of pi minus x, guys. O, tingnan natin later kung bakit pwede. All over, factor out natin yung negative y, ay negative, para maging pi minus y. Yan, okay? Now, bakit ba x na naman to? Magsalita naman kasi kayo. Sir, mali yung nasulat nyo. Sumigaw kayo para malaman kung buhay pa kayo dyan. Sige kayo, baka kayo pagdating ng finals, puro tigok. Shh! Test! Huwag kayo maingay. So we have, ingay sila. So sin of pi minus y. Check natin ha. Matatandaan niyo yung sign of difference. O, sign of difference. Sign of the first, cosine of the second, minus cosine of the first, sine of the second. O, yan. O, anong sin pi? 0. Cosine pi, negative 1. Negative, negative, positive. O, sin y yan. Kaya sa makatuwid, ang sin pi minus y para sa sin y. So, I can write this in this way. O, this is what? O, paras na. Pi minus y, pi minus y. Ilalabas ko yung negative. Para talagang paras na parehas. So, sin of pi minus y. O, paras na yung angle niya sa denominator. Pi minus y, para na siyang sin of x over x. Kaya lang, ang problema natin, dapat, hindi siya y approaching pi. Dapat approaching 0. Ang pi minus y ba nag-a-approach sa 0? Yes, kapag ang y nag-a-approach sa pi. Kapag ang y nag-approach sa pi, kapag daw ang y pumupunta sa pi, magiging pi minus pi, approaching 0. So, pwede ko siyang isulat ng what? Pwede palang palitan ko ang behavior nito. Okay? So, pi minus y approaches 0. O, paras na yan. Pi minus y, ito, pi minus y, approaching 0. So, 1 na yan. Negative 1. So, negative 1. Okay, guys? Hi, guys. Hi, guys. Hi. What about this? last one for this, limit as cosine of sine. Ano bang maganda? X approaches, let's say, cosine of pi over 2 yan. Cosine of, as theta naman. Theta approaches pi over 2 ng cosine of theta over 2 theta minus pi. Yan. 2 times. Tingnan natin. Anong cosine ng 90 degrees? Going to be 0. Cosine ng pi over 2. 2 times pi over 2 is pi minus pi. So this is going to be 0. So indeterminate form again. Ang problema, wala naman tayong pwede makancel para mawala yung 0. So what we do, guys, anong gagawin? Iliwat natin sa format na dapat ang goal natin maging sine function. Sabi sa trigo, yan daw ay para sa pi over 2, sine of pi over 2 minus theta, co-function. Ang cosine 30 degrees, children, ay paras ng sine of 90 degrees, ito yung pi over 2, minus 30, which is sine 60. Yan, complementary functions. Kaya yung theta, palitan ko ng complement niya, pi minus 2, pi over 2 minus theta, cosine magiging sine. Dapat alam niyo sa trigo yan, ha? Okay? Anong problema pag mahina sa trigo, hindi alam to, yung cofunction. So, pi over 2, no? So, eto naman, factor out ko yung negative 2. Magiging pi over 2 minus theta. Yan. Paras na. Pwede ko nang ilabas yung negative 1/2. Limit. And then, pwede ko rin paltan. As x approaches, as theta approaches pi over 2, what happens to 2 theta minus pi? Nag-approach sa, anong nangyayari sa pi over 2 minus theta? Nag-approach sa 0. Kapag ang theta nagiging pi over 2, ang pi over 2 nagiging minus pi over 2, magiging 0. Kaya pwede kong palitan ito nito. Paras lang pala yung behavior niyan. Paras lang ang behavior. Minus theta approaches 0. Paras na ng theorem natin. Paras na yan. Ang angle, pi over 2 minus theta. Ang denominator, pi over 2 minus theta. Ang pi over 2 minus theta nag-approach sa 0. So, equal yan sa 1. Yan, 1. And therefore, it is negative 1/2. Okay, guys? Hi, guys. Nako, ayaw nilang magsalita. Okay. So, we now discuss continuity. Continuity na tayo, ha? Continuity of a function. Continuity of a function. Continuity of a function. Why is continuity very important? What are some applications or ideas of of continuity? Now, you're fond of texting or calling, no? Of course, once you call, you do not want your call to be what? To be terminated, no? Or to be halted, no? O maputol. To be disconnected. You do not want your call to be disconnected. Or you do not want your text not to be what? Not to reach the intended receiver. So you want, of course, your text message to be received by your friend or the receiver. So that's what continuity is all about, no? Similar to that. So we do not want your function to have a graph that is with a problem or with a termination, no? Or with an endpoint or with what? With a problem in general. So, but of course we cannot avoid, no? But how to determine such continuity, discontinuity, if there is in case a not continuity in a function? Okay? So in mathematics, the term continuity has much the same meaning as it has in everyday usage. Informally, to say that a function f is continuous at x equals a means that there is no interruption in the graph of f at a. That is, the graph is unbroken at a and there are no holes, jumps, or gaps. Okay? So this is how a continuous function looks like. A continuous, a continuous function. So, a continuous function ay a a continuous function looks like this. Looks like this graph. Let's say I have y x. Okay. So we have until 8 only, so that you can rest. And then I will just be uploading a lecture, but you have to read. I will just have it in detail. Okay, so this is asynchronous. We call this asynchronous. So you are responsible to read the lecture. So at least I can start with it, with the idea. So this is how a continuous function looks like. There is no hole. So even there is a sharp point, it's all right. As long as it is a function, yan. And it continues without end. Okay? So that is how a continuous function looks like. There is no hole, there is no break, there is no gap. It is when you draw, you can meaning you can draw the graph without lifting your pencil or ball pen. Okay? So do you know how a continuous function looks like, guys? Yeah. But what is really a continuous function? To give a mathematical definition of a continuous function, so let us begin with what we call continuity of a function at a number. So, so again, our goal, our question is question. So what is a what do we mean? What do we mean? So what do we mean by a continuous function? By a continuous function, mathematically. Mathematically. So that is graphically. At least graphically, we can easily what? Recognize it or illustrate it. So we are going to begin with again with what we call continuity. Yan, definition. Continuity of a function at a number, meaning at a value of x. At a number. How do we define continuity of a function at a number? A function, let's call that function f, is said to be continuous at x equals a, meaning at a value of x that is equal to a, if and only if and only if meaning it is both direction, no? Kung meron kayong mathematics in the modern world, it is implied and implies. It implies and it is implied. If then, if P then Q, and if Q then P. So the converse is true. If and only if the following three conditions, the following three conditions are satisfied. Three conditions are satisfied. What are these three conditions to satisfy so that we will be calling a function continuous at a number A? So number one, these are the three conditions. If you get the function value at x equals a, it is defined. Okay? Meaning it exists. The function value exists, is defined. Exists. Huh? F of a exists. The second condition, if I take the limit, the reason why limit is important, no? Connected to continuity. As x approaches that a of f of x, it exists, meaning it is a real number. Okay? It exists. Not infinity, not negative infinity. Not that it is, that the limit does not exist. It should be existing, a real number. So that is a real number. A real number. So that is what it means, ha? A real number. Okay? The third condition that must be satisfied, these three conditions, all these three conditions must be satisfied. The limit as x approaches a of f of x, di ba, it exists and must be equal to f of a. The value of the function must be equal to the limit. If the value of the function at a is not equal to the value of the limit as x approaches a, automatic, not continuous at a. Let's say f of a is not defined. Automatic, it's not continuous at x equals a. If one is violated, not already continuous. If one is not violated, but the second is violated, automatic, they will not be equal. Okay, the third will not be true. So, if the first one is okay, but the second is not, it is violated, the limit does not exist, it is not continuous at x equals a. Okay, guys? So again, if any of the three, if any of these three conditions, fails to hold at x equals a, then the function f is said to be what? Is said to be discontinuous at x equals a. Discontinuous. When you say discontinuous, not continuous. Discontinuous at x equals a. Okay? Not continuous. Take note of the spelling of continuous. Ha? The last syllable ba ang tawag dito? N-U-O-U-S. Not N-O-U-S. N-U-N-U-S. Okay? So, that's the first requirement or the first concept that you need to know in order for a function to be continuous like this graph, no? But this is just one concept that you need to know. So what do we mean by this continuity of a number? Let us have example. Example. Determine if the given function is continuous. Determine if the given function is continuous at the specified x values at the given at x equals the given value at the given at the specified x value x value. Number 1, f of x equals x squared minus 1. X equals, let's say, 0. X equals 1. So we want to know at x equals 0, at x equals 1. Okay, so solution. To check if it is continuous at each of those numbers, so we have to test the 3 conditions. Okay? So first, at x equals 1. Letter A, at x equals 1, ay 0, no? At x equals 0. We have the following. First, what is f of 0? That is 0 squared minus 1. Am I right? So that is negative 1. Check. It exists, no? It is defined. Second condition, what is the limit as x approaches 0 of x squared minus 1? So this is polynomial. We can substitute, no? We can apply substitution rule. 0 squared minus 1, negative 1. Check. Obviously, they are equal. So f of 0 is equal to the limit as x approaches 0 of x squared minus 1. Check. Therefore, we conclude that f is continuous where it is continuous at x equals 0. Meaning, at x equals 0, there is a connection to the immediate right and left of that value of x or of that point on the graph. Okay? So at x equals 0, you can travel to the right and to the left at least, even though it is a small distance, for instance, but at least you can travel guaranteed. You can move to the right and to the left immediate, no? So that's what it means. So, but since this is a polynomial, actually, x squared minus 1, it is continuous at every number. A polynomial has no problem. If you draw the graph, if you are in Gen Math, you see the graph of a polynomial function, it is really without end, continuous. No? So, we can generalize later. If x equals 1, so test again, f of 1, that is 1 squared minus 1, that is 0, check. Second condition, limit as x approaches 1 of x squared minus 1. Again, this is a polynomial, therefore, we actually quadratic, no? So, we can apply substitution rule. Obviously, they are equal. Limit as x approaches 1 of x squared minus 1 is equal to f of 1. Check. So, we conclude that f is continuous, also is continuous where yan, at x equals 1. Okay? Any question, guys? Still alive? Ay, guys. Ay, guys. Nabawasan na tayo. 13 na lang kayo. Yung isa sumuko na. Naubos na data. Guys. Ay, naririnig ba ako, children? Ay, guys. Guys. Ay na. Okay. Okay? So let's have the second one, number 2. Our function is f of x, which is equal to x plus 1 all over x squared plus I minus 1. X plus 1 all over x squared minus 1. I want it at x equals, ayan, at x equals 0, tsaka at x equals, and x equals negative 1. Okay? I want it to be at those values. So first, let's have at x equals 1. By the way, I can generalize here. So, the polynomial, if you have a polynomial function, remark, I will put the remark. If f is a polynomial function, is a polynomial function, ayun, so let's have a polynomial function. A polynomial function, ba't ba ganun? A polynomial function, you know guys, a polynomial function, ha? Linear function, constant function, linear function, quadratic function, cubic function, lahat ng exponent ng x, positive integers. Except pag constant function, no? So, 0 ang coefficient, ang exponent ng x, kaya just constant. A polynomial function is continuous at every number, at any real number. At any real number. Kahit paano ilagay mo sa x, continuous, kahit wag mo nang i-test. Continuous yan. Meaning, laging defined ang function value, laging may limit as x approaches any number. Yan. Okay? So, what about this? So, first, let's test. At x equals a, 0 I mean. So, test natin. Ano yung f of 0? That is 0 plus 1 all over 0 squared minus 1. That is negative 1, right? What is the limit? That is how to test. Kaya if you're asked to test if it is continuous at a given number, that's how you do it. Of x plus 1 all over x squared minus 1. So, hindi naman nag-0 ang denominator, no? We can apply substitution rule. Still, negative 1. Are they equal? Yes. No? Limit as x approaches 0 of x plus 1 all over x squared minus 1 is equal to f of 0. Check. Okay? So, therefore, what is our conclusion? It is what, guys? F is continuous. That quotient is continuous at x equals 0. Okay? Oh, what about at x equals negative 1? Oh, first, we have f of negative 1, that is negative 1 minus 1 all over negative 1, quantity squared minus 1. So, negative 2 over 0, undefined. Hindi to limit, ha, kaya pwede ko isulat yung 0 sa ilalim. But that is undefined. Okay? O, number 2. Actually, automatic na hindi na siya nag-exist. Ang what? What we call this? Automatic, this is not anymore continuous na. Yan. Conclusion natin, yan. Kasi hindi na kahit mag-exist pa limit, hindi na rin. No? Oh. Okay? Check natin yung limit. Yung limit actually. Pag check mo ang limit, yan, ng x plus 1 all over x squared minus 1 Equal yan sa limit as x approaches negative 1. Mapapactor out to x plus 1. Ito, makakancel. May matitira sa ilalim na x minus 1, no? O, negative 1. So, ang limit niya ay negative 1 over negative 2. O, negative 1 half. Nag-exist sa limit, pero, of course, yung third condition, so limit, hindi naman equal ng x plus 1 all over, violated yung number 1 at number 3. Not equal sa, okay? So, this is okay, but this is not. So again, ito pa lang, okay na to, enough na to. Babox ko ha, kaya ibig sabihin binox ko, enough na to, kahit wag na kayo mag-solve nung, ay, hindi pala siya nakabox. Paano ba mag-box? Babox ko pala, ibabox. Yan. Ibig sabihin, ito ay enough na para sabihin, ay, ano ba yun? Enough na yan para sabihin, yan, okay na yan. Okay? So, pwedeng kahit wala na to. Can be omitted na to. This can be, yan, can be omitted. Can be omitted. Kung gusto nyo, kumplituhin nyo, mas mabuti, masipag kayo. So, we conclude that, because this is violated, f is not continuous. It's not, meaning discontinuous. It's not continuous, meaning, ano siya? Discontinuous. May problema siya sa x equals what? Yan, x equals at x equals negative 1. Okay? So, actually, it is a whole there. It is a whole. Now, pero merong kagandahan pa rin sa rational function. No? Remark natin. Basta nasa domain. Meaning, kapag daw ang function value ay okay, no? So, nasa domain siya. Continuous ang what? Ang rational function. Remark. Yan ha. A rational function, alam niyo yung rational function ha? Yun yung quotient ng two polynomials. A rational function is continuous, yan, at any number, real number. When I say at any number, I mean real number. At any real number in its domain. In its domain. Basta nasa domain niya. Okay? Basta yung x nasa domain. Yung negative 1 wala sa domain eh. Undefined siya din. Pero yung 0 nasa domain. Yung 1 ba nasa domain? Wala rin. Yung 3 nasa domain? Yes. Continuous siya sa 3. Basta nasa domain. So, ibig sabihin, hindi lang siya continuous sa negative 1, positive 1. Okay, guys? Guys, ayaw nilang sumagot. Now, how does the graph of a discontinuous function look like? No? How does a graph of a discontinuous function look like? And this time, let us talk about function with a problem. No? Yun tayo interesado. Kasi pag walang problema, hindi tayo interesado kasi walang problema yun. What can we do about those with problem? Graphs of functions discontinuous, yan, at a number x equals a. Okay? Now, ito yung mga possibility. Pero I'm not guaranteeing that I will able to give to you all. Pero ito yung mga common, no? So this is y, x, y. So the graph looks like this. So this is, let's say, my graph, but there is a hole here. So then, like this. So at x equals a, so it is discontinuous there because there is a hole. Okay? So another, yan, if I have this one, etong graph naman na to, meron din siyang hole, pero ang problema lang naman, at defined siya, pero may hole pa rin, no? Yan. Pero define ang function. Let's say, ito yung point. May point yan. Pero may butas pa rin doon. Hindi pa rin continuous yan. Nag-exist ang function kasi may value. Pero, merong problem pa rin. No? Ang limit niya, nag-exist pero hindi equal ang function value sa limit. Yan. This is our A. Okay? Anong case yan, children? Anong case to? Anong problema rito? Ito, ang function value, ang violated dito, is undefined. Is undefined. Undefined. Dito, ang function value is defined, exists, but limit also exists. Ang limit dito nag-exist. May limit yan eh. As x approaches a, ito yung limit niya, yan o. Yan. Which is L, exists. Okay? Pero hindi equal. Pero ang f of a not equal sa limit. Notice that ang function value ito. Halimbawa, ito yung value. Let's say it is equal to d. But f of a is not equal to the limit. Violated yung 3. Okay, guys? Yan. That is one possibility. Another possibility, we have another possibility. Ito. Yan. We have this is, let's say, and I have this vertical asymptote. This is my graph. I want it W1. W1. Okay. So it goes like here, it goes there, and then here it goes here. That's the graph of the function. Okay? And this is x equals a. So, anong value sa function sa a? Undefined. Undefined. Okay? Yan. But, undefined. So, that's the reason why it's not. No? Pero let's say, lagyan ko ng value. So, defined siya. Defined siya din. Pero, ang problema, ang limit niya. O, gagawin kong defined siya. Pero, of course, automatic pag undefined. So, exist, no? Pero ang problema, but ang limit, hindi nag-exist. As x approaches a, both from the left and from the right, kapag tinake ko ang absolute value ng f of x, yan, kaya para hindi na negative infinity, positive, lagi ng positive infinity. Kasi naka-absolute value. So, as x approaches a, going up, positive infinity, going down, negative infinity. Pag tinake ko yung absolute value, positive infinity, does not exist. Therefore, discontinuous at x equals a. Another possibility, yung may ganito. Maaring mag-exist ang limit. Maaring define ang function value. Tulad niyan. Ayan. Ay, that is a bit color. Itong blue. So, we have, ito halimbawa, yan. Then, I have a continuation of the graph here. Butas. Let us have, then, I will now draw the graph like that. So, this is x equals a. Walang problema sa value ng function, no? Define there. Ito halimbawa yung value. This is c. Ang f of a ay equal what? Sa c. Defined. No? Or it exists. Ang limit nag-exist from the left. Pero hindi nag-exist from the right. Pero hindi equal. Therefore, hindi pa rin nag-exist ang limit. Does not exist na. Di ba dati, may limit tayo dyan. From the left, nag-exist. From the right, pero hindi equal. So, does not exist. Therefore, discontinuous pa rin. No? Therefore, ang f of a hindi equal sa limit of f of x as x approaches a. Okay? Yan. Ito yung mga common, no? Graphs of functions na discontinuous. At may mga special names yung mga discontinuity niyan. Okay? May mga special name. So, we begin with what we call what particular, I think we have, by the way, ito maraming cases to ha. Ito, maaring ang graph niya, pag ganito, another case, halimbawa ganito, parehas going up, maari namang parehas going down, ang graph, maari namang going up, going down, at maaring defined. Of course, sabi ko sa inyo, maaring defined. Ito naman, pwedeng kalahati lang, maaring ganito lang, maaring ganito lang. Yan, no? So, discontinuous pa rin siya kasi discontinuous from the left. O maari namang sa kanan lang, patas-butas pa. Okay? Yan, mga ganyang case. Okay, guys? Yan. May tinatawag na continuity on one side lang. Kaya ito, continuous from the right. Pero hindi continuous from the left. Ang totally not continuous. Pero kung right lang naman ang gusto mo, okay naman to. No? Ayun yung one-sided continuity. We call this one-sided continuity. So, let's talk about one-sided continuity. One-sided continuity of a function. One-sided continuity. Continuity of a function. So, let f be a function. Let f be a function. And let A together with L be real numbers. Be real numbers. Number one, we have what we call right-hand continuity or continuity from the right. Right-hand continuity. Right-hand continuity. What do we mean by right-hand continuity of a function? Let's call it f at a. A function f a function, let's call it f, is said to be continuous from the right, meaning right-hand continuous. Continuous, said to be continuous from the right, that is right-hand continuous ha, that is right-hand continuous, paras din lang yon. Right-hand continuous. At x equals a, if and only if the limit as x approaches a of f of x is equal to f of a, and that is, let's say, equal to L. Okay? They are equal and it is a real number. No? The value of each, which are actually the value of, their values are the same. Okay? If the function value exists and the limit exists and they are both equal to L, which is a real number, then it is continuous at that number. No? From the right. So graphically, this is how it looks like. Graphical. And this is, let's say, this is my point. That is my x equals a. Then the graph goes like this. No? Yan. So, continuous at this point. And of course, at every point here, continuous. But at this point, which is a problem, it is continuous from the right, but not from the left. Totality, it's not continuous, ha? Pero continuous from the right, or it is right-hand continuous. Okay? So again, we call this right-hand continuous. What about if I have continuity from the right, I mean from the left? Ano naman ibig sabihin ng continuity from the left? So left-hand continuity. Left-hand continuity of f at a. So what do you mean by that? Again, a function, let's call it f, is said to be continuous from where? From the left. So that is left-hand continuous, no? Left-hand continuous. At x equals a, if and only if. If I write IFF, it means if and only if. Limit as x approaches. By the way, this is may plus dito ha, kasi from the right. A from the left. Again, from the right may plus doon. From the left, so A approaching, x approaches A from the left. Of f of x, and that is equal to f of A, which is equal to L, for instance. Okay? Graphically, this is how it looks like graphically. So we have, let's say, I have this. This is a point defined there. So that is x equals a. Okay? Do you have any question, guys? One-sided continuity. Yung kanina diniscuss natin, two-sided. Ito, one-sided. One-sided continuities. So, left hand and right hand continuities. Pwede pa rin pala maging continuous. Pero from the left lang to. Ito from the right. Pero totality, pag two-sided ang pinag-usapan, hindi sila continuous, ha? Pero pag one-side lang, pwede maging continuous. Okay, guys? Guys, there are three common types of continuity. Types of continuity. Continuity of a function. At a number. Number one, we have what we call removable or missing point discontinuity. Removable or missing point. May mga book, pero bihira na tong term na to eh. Missing point ang tawag. Ito yung whole. Missing point discontinuity. Discontinuity. Okay? Pwedeng removable, pero ang sikat ngayon removable. A function, let's call it f, is said to have a removable discontinuity or missing point. A removable discontinuity. May pag-asa pa palang matanggal ang discontinuity. Kaya inaaral natin yung mga discontinuity. So, at x equals a, let's say we want to talk about a, ha? At x equals a, if what? If limit as x approaches a of f of x exists, nag-exist ang limit, but ang f of a hindi equal sa limit as x approaches a of f of x. Okay? Nag-exist ang limit. Yan. Pero, ang value ng function hindi equal sa f of x, limit ng f of x as x approaches a. So, ito yung mga possibility. Graphically. Ito yung mga possibility. Walang sinabi about function value, no? Anong sabi sa function value? Wala namang sinabi. Basta hindi lang equal siya sa limit. So, anong possibility ng function value? Pwedeng defined, pwedeng undefined. Pero ang limit dapat nag-exist. Okay, guys? So, ito, yung function natin. So, butas siya, function is not defined. Pero nag-exist ang limit niyan. Diba may limit yung case na ganyan? Okay? So, again, ang case na to, ang f of a, undefined, is undefined. But, ang limit as of f of x, as x approaches a, exists. O, nag-exist ang limit. Ito naman, f of a is defined. Is defined. O, drawing natin defined dapat. And the limit, but the limit, again, and limit of f of x exists as x approaches a, but they are not equal. But automatic hindi na sila mag-i-equal. Ay, no. Pero possible mag-equal. Pero for this case, dapat hindi sila equal. Yan. As x approaches a. Nag-exist ang limit, define ang f of a, pero hindi equal ang function value sa limit, removable yun. Yan. Ito yung case na yan. Ito yung function, pero defined ang function. Let's say may point dito. O, merong value ang function. Yan. Okay? So, there is a point here. Pero ang limit nag-exist, hindi nga lang equal sa function value. Okay? O, number 2. Yan yung case ng, what about number 2? Ang number 2, we have what we call infinite discontinuity. Yan. Infinite, hanggang ano lang tayo, hanggang types. Infinite discontinuity. Then, I will just upload a lecture notes which you are going to read, no, and study on your own. Continuity. Infinite discontinuity. When do we say that a function has an infinite discontinuity? A function has an infinite discontinuity. Infinite has an infinite discontinuity. Discontinuity. Yung may mga book ang tawag asymptotic discontinuity. Asymptotic discontinuity. Infinite discontinuity. At x equals a, if f of x increases, if the value of f of x increases without bound, walang hanggan, no? Without bound, parang walang dulo, without bound, as x approaches a, okay? As x approaches a, that is the limit as x approaches a of f of x is either positive infinity or negative infinity. Okay? O kaya just infinity or just negative infinity, or a combination from the left positive infinity, from the right negative infinity. So, okay? How does it look like graphically? How do we illustrate that? Ito yung mga possible case, no? Yan. Ang graph niya, ito, going that, and asymptotic there. Asymptotic. That is one case, no? Another case, opposite ang direction sa asymptote. Let's say, ito yung asymptote. Ang direction niya opposite. Going down, ito naman, going up. Okay? Meron naman para sa pababa. Ito yung mga possible cases. No? Basta approaching a certain vertical line. No? Yan. Maaring paras naman pababa. Yan. Paras pababa. Ito naman, meron pa akyat, pababa. Okay? Yan. So, itong case na to, ang limit dito, positive infinity. Dito, ang limit as x approaches a, ito yung a eh. Dito, from the left, negative infinity. From the right, positive infinity. Totality does not exist, no? Ito, from the left, negative infinity. From the right, negative infinity. So, infinite discontinuity up x equals a. Okay? Then the last one here, number 3, we have what we call jump discontinuity. Jump, yan, ay, kapal masyado. Jump discontinuity. Yung ibang book, finite jump, no? May mga book, finite jump, or simply jump. Jump or finite jump. Yung iba, finite jump. Finite jump. Yan, finite jump. Mukha bang finite jump to? Finite jump. Jump or finite jump discontinuity. Discontinuity. Oh, when do we say that a function has a finite jump discontinuity? Guys, what do you think? A function, let's call it f, has a finite jump discontinuity, or simply jump, no? Has a jump discontinuity at x equals a if ang limit as x approaches a from the left and limit as x approaches a from the right of f of x both exist, nag-exist sila. Both exist, but unfortunately not equal. But the limit as x approaches a from the left is not equal to limit as x approaches a from the right. Nag-exist, hindi nga lang equal. Okay? So, to illustrate, ito yung case of jump discontinuity or finite jump. Here we have going here, nag-exist from the left, nag-exist ang limit from the right, pero hindi naman equal. Etong case na to, nag-exist from the left, nag-exist din from the right, not equal nga lang. Di ba, limit niya from the left, from the right, nag-exist. Hindi nga lang equal. Okay? Dito ang function value, undefined. Dito, f of a, defined. Okay? Pero ang limit, as x approaches a from the left of f of x, not equal to the limit as x approaches a from the right of f of x. In any case, in any case, no? Pero nag-exist ang limit from the left and from the right. Okay? This exists. It exists. This exists. Pero they are not equal. Okay, guys? The next topic that I'm going to have supposedly continuity on an interval. But I will just be uploading to you. As long as you know this basic about continuity, then you will able to answer what? I understand continuity on an interval instead of at a number on a collection of numbers. Okay? Yan. Now, I will just have one example. I'll just upload. And then you just look at it. No? I will just upload this. In case you have questions, you just PM me. Do you have any question, guys? Guys, do you have any questions about this? Guys, before we leave. Okay. Hopefully you understood. And then in case there are things that you are confused, you just PM me. Okay? Or you look for some videos. Kaya lang be careful when watching videos, ha? Who uploaded the videos, no? So, and also how they write. Because not all writing mathematical structures correct, no? Okay. So, goodbye guys.